In this video, we will be making some adjustments to the project based on the suggestions and comments that you guys have made on the earlier videos of this series. So before we start, I would like to say thanks to everyone that commented and came up with suggestions for what we could do differently or what we could do better, because if you come up with a suggestion for how something could be done in another way, I often test it out, and if I find that your way is better, then of course I would like to include that into the tutorial, because I would like the tutorial to be as clean and good as possible. The first few things I would like to change has something to do with the movement system. The movement system right now is using something called transform to translate to move our player around, and if I play the game it looks fine here on this computer or this device I'm using now, but I've tested this game on other devices and actually the movement isn't very smooth on all devices I'm using. So instead of using transform to translate, which isn't very precise, I would like to use the physics system to move our player around to get a more precise movement, and it will also make it easier for us later when we have to deal with physics like collisions, for example. Before we can use the physics system to move our player, we will have to add a component called a rigid body. A rigid body is something that we add to an object when it needs to interact or use physics in the game. For example, if you need gravity on an object, you will have to add a rigid body to it. For example, we can click add component. If you write a rigid body or rid, you can click the rigid body 2D. Remember to use rigid body 2D because we're working in 2D here. If I would play the game now, you will see that my player just falls to the ground, as you can see. And that's because it has a rigid body on it and it has gravity on, so it falls to the ground now. Our game is a top-down game, so we don't need gravity on the player, so we can simply just select him and then we can go to the gravity scale and set it to 0 to make sure that he doesn't have gravity on him. Besides that, I would like to set some constraints. I would like to freeze the rotation so that he doesn't fall over or something if he bumps into something in our game world. If we forget to freeze this rotation, he might hit a tree or something and then tip over, and that's not what we want. What else? So now we have this rigid body on him and we can start adding or moving him with the physics system. So first of all, we need to rewrite some of the movement function. The move function here needs to say access the rigid body instead of transform to translate. So if I go up here and I say private rigid body 2D my rigid body, and I would need to make a reference to the actual rigid body here on the player, so I have reference to this. To do that, I simply go here and say my rigid body equals get component rigid body 2D. So now I have a reference to the rigid body and I can start using it. When I have that reference, I can go down to my movement function and I can actually delete this line of code I already have. Then I can say my rigid body dot velocity is equal to direction multiplied by speed. Notice that I didn't use the time to delta time here, and that's because we are now going to use the physics system to move him, which is frame rate independent. So instead of using update, which isn't frame rate independent, because update runs every frame, so if I have 100 FPS it runs 100 times and so on. So instead I would like to use my fixed update. So I can write private void fixed update, and fixed update should be used every time you actually manipulate with a rigid body. That's why you should fixed update, to make it frame rate independent. So I'm going to call move in here. Instead, I'm going to delete move from update. However, some of these things down here are not meant for fixed update. For example, I would like to animate my movement right away and would like to set my layer weight correctly and check all these things actually on the fly, or like as fast as I can. So instead of having all this in move, I would like to cut it out. Go down here and make a new function called we can call it handle layers. This is going to handle our animation layers. Okay. So handle layers needs to be called in update. So go to update and write handle layers. So if I save this now, and I will go back to Unity and play the game, then I should still be able to move my character around exactly as I did just before. Everything should work exactly the same. The only difference is the fact that we're using the physics system right now to move him. Another thing we will have to fix is the fact that our player actually moves faster when we hold down 2 keys at the same time. So you can see if I walk to lift and I press up and lift at the same time, he actually moves a little faster because I'm pressing 2 keys. So in our game right now, it is always faster to move diagonally instead of moving horizontal or vertical, as you can see. So how do we fix this? Well, it's very, very simple to fix that. We will have to make a vector with a magnitude of 1 by normalizing our vector. Because right now we are using direction here and we're just adding to it all the way down here. And what you have to do is to normalize it so you get a 1 unit vector so that it is maximum 1.1 instead of 2.2, for example, which is a higher value than a unit vector, right? So what we would like to do is to normalize this direction before we apply the speed and before we use it for our velocity on our rigid body. So how do we normalize it? Well, it's very simple to normalize it. So let's say that we press a lot of keys and our vector turns out to be 2.2, for example. 2x is equal to 2 and y is equal to 2. Then we normalize our vector and we will actually get a vector that looks like this instead. So it actually takes the vector and normalizes it so it gets a length of 1 in all directions. And even if this was 20.2, it will also normalize it to 1.1, so we just get the direction. And we do that by saying direction dot normalized. This will not change the vector direction, means that direction is still the same value as it was before, but this will return direction as a unit vector. If you like to change the actual vector, you can use the normalized function here instead. But I'm simply going to say direction dot normalized just to get the vector as a normalized vector and use it so we don't change it. Yeah, so that's totally fine to do. So right now when I've done this and if I save this, it should look very different now when I'm moving. So now you can see it doesn't go faster when I move up. I actually move the same speed if I move diagonally and if I move horizontal or vertical. I would also like to add a few things that will make some of the coding easier for us later or make the code a little more clean. First of all, right here we're checking if our direction x and y is different, just to check if we're moving or not. I know for a fact we're going to need to check if we're moving or not at other places as well later in the code. So instead of just writing this if statement, I would like to make a property so that I can check if I'm moving as a character. So I can make a public bool called isMoving, and it's simply going to have a get in it, that property here, and it's going to return this down here, like so. So this property actually takes this condition and returns a boolean based on the outcome of the condition here. So we can actually use this property to figure out if we're moving or not. And that means we can go down here and replace this with isMoving. And the reason that I did this is because it's just more cleaner, it looks better, and we're going to use this isMoving later to figure out if we can cast a spell and stuff like that. So that's gonna help us out later. So now that we have done that, we can actually also add an other function to our to our script here, because right now you can see we are using something called set layer weight, and that's also something we're doing in a lot of places. Animate movement also have set layer weight here, and we're also going to use it every time we're going to attack and do other things. So actually I can make a function for our characters to change the layer. So let's make a public void activate layer, and this will make it way easier for us to activate a specific layer. So let's say we have 5 layers or more layers, because right now in our player we have 2 layers. But imagine if we have more layers and I need to activate layer 3 or something, or 4. If I activate layer 4, then I need to make sure that this one is 0, this one is 0, number 3 is 0, and then number 4 needs to be set. So the more layers we get, the more layers we have to disable before we can activate a new layer. And that means that if we are activating layers here, for example, well, then I need to make sure that the other layers are disabled. So I need to write an extra line of code here to say, well, when I activate layer 1, then layer 2 needs to be 0, for example. And also we have a third layer, so layer 3 also needs to be 0. And we have lots of other places where we're activating layers, so we have to copy this and paste it up here as well. So to avoid that, I would like to make a function that makes sure that our layers are disabled when we activate a new layer. So let's make a for loop, and we can actually use our animator. And we don't have a reference to our animator right now, do we? Yes, we do. We have animator here. To make it easier to distinguish it or find it, I would like to rename it to my animator, so I don't confuse it with something else. You can keep it as animator or rename it, that's up to you. The easiest way to rename is just right click and click rename here, or press F2. Then I'm going to use my animator dot layer count. So this will take the amount of layers I have here. So it's 5, then the layer count is 5. When I use the layer count, I can loop through the animator, my animator dot set layer weight, and make sure that every single layer I have in my animator, or in my animator, has the layer weight of 0. And I want to set, if I could write correctly, set layer weight. There we go. So now it's going to run through all the layers and set them all to 0. When I'm done with that, I need to enable one single layer, and the layer I want to enable is the layer name up here. So I say animator dot set layer weight, animator, my animator dot get layer index, layer name, and I want to enable it to be 1. So when I use a string, let's say I call this idle layer, it disables every single layer, including the layer that I'm going to use. And then we go down here and take the animator, we set the layer weight, and then we get the index of the layer name here. So we use a name to get an index, and we enable it by setting the weight to 1. And that means that we go through all the layers we have over here. We use walk layer, for example, we want to call walk layer. It finds walk layer based on the index here. This here will return 1, and then it will set it to 1. So this, if we call this function with the walk layer string, it will be the same as say my animator dot set layer weight 1 1. If we call this activate layer like so, walk layer. If we did this somewhere in our code, this would be the equivalent. But now we have this function, so we don't need to do that. So now that we have this function, we need to remember our layer names. We need to see we have a walk layer without a space. It's very important that we write it exactly the same way here. So let's see, we have layer 1, we disable it. So this will make us go back to idle. So actually we need to say activate layer, idle layer. So this will activate our idle layer. We have this animate movement function, and basically we don't really need it anymore. I would like to move it up and handle layers instead. I'm going to take the content of animate movement and move it up here so that I have it inside my function called handle layers instead. So the first thing I have to do is to say replace this with activate layer walk layer. That's my walk layer now, and I can actually delete this and delete this. Now it's a little more clean. So handle layers will make sure the right layer is activated no matter what. When we get attack, we will add attack here, down here, but we don't need that right now. That's another video. So now I think we have cleaned up a bit and made it easier for us later when we have to add in some more things. So if we save this, we should still be able to do the exact same thing as we did before. Play the game, we should be able to idle, go to the right, idle, up, idle, so on. So everything still works exactly the same way. So the next thing I would like to do is to make sure that we handle our animations a little better, or it may a little less complex or complicated. So if we go to the idle layer, we can right click and to create state from new blend tree, because I also got a suggestion about blend trees, and I figured, yeah, blend trees are often used. Every time I use them, I've only used them in 3D because they're very useful for 3D animations. You can blend animations together and stuff, but actually I figured you can use them for 2D, and it also makes it easier to get an overview of what's happening. I also read some posts, some of you guys also posted some links about what you could do in an RPG, and there was also a guy who suggested that you can use blend trees, but he is doing it a little different than I'm going to do, because he's going to use a controller for each animation. I'm not going to do that. I'm going to use blend trees and layers. So I think that's a way better solution for doing this, and you'll see why when we're done with this. So let's see, we can have blend tree. A blend tree is actually a way of blending animations together. And right now, we're not going to blend them together because we have 2D, but we're going to make the blend tree actually switch between animations for us. So a blend tree has a parameter, and right now it's a 1D tree, which means that it switches on one parameter here. Well, we have X and Y values. So instead of one parameter, we would like to change this into a 2D simple directional blend tree, which means that it has two parameters, one called X and one called Y. So make sure you go up to parameters here and select the one as X and the second one as Y. Then you can see now you have two parameters. When you've done that, you can add some motions. You can just click the plus here a few times and add motion fields, and you can do that so that you have 4 motion fields. In here, you will actually have to add the animations. This blend tree here is for idles. So let's go to animations, find idle, and make sure we add idle down first, and then we add idle up, then we add idle right here, and then we add idle left. So based on the order here, it will play an animation when you have more keys pressed. Or how should I explain it? That was very bad said, badly explained. So let's say you press down and right at the same time. Based on the order here, it will play down or right. If down comes first on the list, well, then down will be played when you press left and down at the same time, or right and down at the same time. If you would switch them around, so left is before down, and you press left and down, then it will animate him to the left instead. So it's up to you how you want it. It's just important. We are going to create a blend tree for every single layer here, both the idle and the walk. It's very, very important that you put them in the same direction, in the same order. So if the animations are down, up, right, left in the idle layer, they need to be down, up, right, left in the walk layer as well. Okay? So idle down, well, idle down is played when X is 0 and Y is -1. Idle up is played when X is 0 and Y is +1. Idle right is played when X is 1 and Y is 0. Idle left is played when X is -1 and Y is 0. There we go. So now you'll see all my animations are actually spread out here, up here in the preview. So you can see I can actually change this. Let's say X is 1, then it leans towards walking to the right. Then Y becomes 1, so it goes up here. And then X goes down, so it goes to minus, and then it goes to the left and right. So if this was 3D, it would blend the animation for walking up and walking left, so you would walk diagonally instead. But right now it's 2D, so we can only play one of the animations, and we have chosen to play the up animations over the right animation, right? So let's try this. If this is set up, I should be able to go back here and say, well, my blend tree is my default state now. So when I play this, he should still be able to idle in the correct direction when I let go of the keys. And as you can see, it works fine. Okay, so now that we have done that, we need to do the same for our walk layer. We go down here, and actually we can just take the blend tree here and copy it and go down to walk and right click and paste. Then we go down here and we delete all the walks, and we go up in idle actually, and we delete all the idles. Right now this one is called blend tree both places. You can actually select it and rename it to idles in the idle layer, and you can rename it to walks in the walk layer. Makes it easier to understand what it is. Anyway, if we go to walks, we can go in here and we can change the motions. There are motions here. We need to have idle walk down, we need to walk to the left, we need to walk to the right, and we need to walk up. So if I play this now, you'll notice that he actually still works as he did before, and you'll see that if I press right and hold down, he will walk down or show the walk down animation. If I press up and press left and press up, he will show the up animation, and that's because my up and down is prioritized or higher than the right and left. So if you want him to walk to the sides instead, you will have to move these up instead of up and down. If I would do like this, like so, you'll see that left has now taken over. He will play to the left when walking up and down at the same time, and right when walking up and down at the same time. But again, it's up to you how you want it. So let's do down and up. Wasn't it down and up? Let's see. Down and up. There we go. Just make sure it's the same as idle, so he idles in the right direction. Yeah. So I think that's it for this video. In the next video, we are all set to start adding our attack, so we can actually make an attack animation in the next video. And then later we'll actually shoot some fireballs or something. So thanks for watching. Thanks for watching my video. Please remember that InScope Studios is a community founded page, so please consider clicking the support link on the screen to see how you can support me and get something back in return.